Good morning, sixth graders. So today we're going to take a look at lesson 28, two-step problems. So let's start with our classwork problem. So it says that Juan gained 20 pounds since last year. He now weighs 120 pounds. Rashad is 15 pounds heavier than Diego. And if Rashad and Juan weighed the same amount last year, how much does Diego weigh? We're going to let J represent Juan's weight last year in pounds and D represent Diego's weight in pounds. So we're going to start with drawing a tape diagram to represent Juan's weight. So Juan has gained 20 pounds since last year. So we'll say that this is his last year. And then he's gained 20 pounds. And he now weighs a total of 120. And we know that Rashad is 15 pounds heavier than Diego, and Rashad and Juan weighed the same amount last year. So Rashad's tape diagram is going to be about the same length as that J part of Juan's tape diagram, but Rashad is 15 pounds heavier than Diego. So Diego is just going to be that D part. So let's take a look at some equations. Actually, let's look at the tape diagrams all together first. That'll make the equations a little bit easier. So we'll start with Juan's tape diagram. And then we'll put Rashad's underneath that. And then finally Diego's. So using that information, we can write some equations. So first we can write the equation for Juan's tape diagram. So we can say that J plus 20 equals 120. So then Rashad's tape diagram, we can kind of use two equations to do this. So since Rashad is the same or weighs the same amount that Juan did last year, we can start by saying J equals D plus 15. So now we're going to take that J equals D plus 15 and plug that into Juan's equation. So we'll have D plus 15 plus 20 equals 120. So that's how we're going to use that to help us to figure out Diego's weight. So we'll use that equation, D plus 15 plus 20 equals 120. So we can add these together. So D plus 35 equals 120. I'm going to rewrite it so that I have a little bit more room. And we're going to subtract 35 from both sides so that we can isolate that D on one side of the equal sign. 35 minus 35 is 0, so that cancels out. And we're left with D equals 85. And to check, we could plug this back into the equations and we'd be left with the true statement. So D is equal to 25. So let's take a look at our next example. So this example says that Marissa has twice as much money as Frank. If Christina has $20 more than Marissa. If Christina has $100, how much money does Frank have? So F is going to be the amount that Frank has, and M will be the amount that Marissa has. So first we'll draw a tape diagram to represent how much money Frank has. So Frank is just F. Marissa has double what Frank has. So she has a franc plus a franc. And Christina has $20 more than Marissa. So we'll take that whole amount that Marissa has plus 20, and we know that Christina has $100. So if we look at all three of these tape diagrams, which of them is going to give us enough information to determine what the value of M is? Well, we're going to have to use Christina's. So we know that M plus 20 equals 100. So to isolate the M, we'll have to subtract 20. Since we're adding 20 in the original equation, subtracting is the inverse. So 20 minus 20 gives us 0. So we're left with M equals 80. The identity property that we've discussed during this module tells us that we can do that. We can subtract M plus 20 minus 20 and it'll equal M. The 80 represents $80 that Marissa has. So now that we know that Marissa has $80, we can use this information to find out how much Frank has. So let's go back up to our tape diagrams to help us to write an equation. So if we know that M equals 80, so then this F plus F has to equal 80. So our equation could be 2F equals 80. So to solve this, since we are multiplying, we'll have to divide to isolate our F, and we're left with F equals 40. The identities that we've used throughout this module tells us that we can do that. We can look at 2F divided by 2, and we'll be left with F. 40 represents the $40 that Frank has. And does 40 make sense in this problem? Yep, because Frank has $40. Marissa has double that, so she has 80, and Christina has $20 more. So it fits into that problem. So let's take a look at a couple other examples. So if we look at our first example, or our next example rather, it says Rihanna is twice as old as Madeline, and Laura is 10 years older than Rihanna. If Laura is 50 years old, how old is Madeline? So let's start with some tape diagrams. So we know that Rihanna is twice as old as Madeline. So we can say that this is Madeline. Rihanna is Madeline, but doubled. And Laura is 10 years older than Rihanna. And we know that Laura is 50. So using this information, we need to figure out how old Madeline is. So we're going to start with figuring out how much or what Rihanna's age is. So R plus 10 equals 50. We subtract 10 from both sides. We're left with R equals 40. So Rayanna is 40. So if Rayanna is twice as old as Madeline, we can use the equation 2m equals 40 to figure out how old Madeline is. Since we are multiplying, we'll have to divide to isolate our variable. We're left with m equals 20. We can kind of plug that in to make sure it makes sense. If Madeline is 20, Rayanna is twice as old as Madeline, so 20 plus 20 gives us 40. And Laura is 10 years older than Rayanna, so 40 plus 10 gives us 50. And we know that Laura is 50 years old. Let's take a look at the next example. So this example says that Carly has 90 apps on her phone. Braylon has half the amount of apps as Theus. And if Carly has 3 times the amount as Theus, how many apps does Braylon have? So we're going to start with Carly. So we'll say that this is Carly. And we know that Carly has 90 apps. We know that Carly has 3 times the amount as Theus. So we can divide Carly into 3, and each of those pieces is the amount that Theus has. So that means one of these is Theus, and Braylon has half the amount that Theus does. So we could say T divided by 2 for Braylon, or 2b for Theus. So we need to know how much Braylon has. So first we need to figure out how many apps Theus has. So we know that 90 equals 3t. So since we're multiplying, I'm going to divide to isolate my variable, and I'm left with t equals 30. So Theus has 30 apps on his phone. Now we can either divide or we can multiply. So I'll show you kind of both ways that we could solve this now. So we could either say that 2b equals 30, or we can divide 30 divided by 2 equals b. Either way, we're going to find the same answer. So we can divide by 2 and divide by 2, and we're left with b equals 15. Or if we chose to divide, we divide 30 divided by 2, and we're left with b equals 15. So either way, Braylon has 15 apps on his phone. We can kind of plug that in because we know that 2 times b gives us 30, and 30 times 3 gives us 90. So we're good to go. Let's take a look at another one. This one says, Reggie ran for 180 yards during the last football game, which is 40 more yards than his previous personal best. Monty ran 50 more yards than Adrian during the same game. If Monty ran the same amount as Reggie ran in one game from his previous personal best, how many yards did Adrian run? So I'll let R represent Reggie and A represent Adrian. So I want you to take a minute and I want you to pause the video here and I want you to try to work this one out on your own for a minute. If you get stuck, you can unpause the video and we will work it out together. All right, so let's take a look at this. So we're going to start with our tape diagram for Reggie. So Reggie ran 180 yards during the last football game. So we'll say that this is that 180 yards, which is 40 more than his previous personal best. And it says to let R represent his previous personal best. So Monty ran 50 more yards than Adrian during that same game. And Monty ran the same amount as Reggie from his previous personal best. So then that means that Monty is equal to R. It says that Monty ran 50 more yards than Adrian during that same game. So we can also think of this as being Adrian plus 50. And that would be Adrian. So we need to know how many yards Adrian ran. So we can start by solving for R. So we know that R plus 40 equals 180. So we subtract 40 from both sides. We're left with R equals 120. So we know that R equals 120, and we also know that Adrian plus 50 yards is the same amount as Reggie's previous personal best. So we could also say that 120 is equal to A plus 50. So we're going to subtract 50 from both sides. And we're left with 70. So Adrian ran for 70 yards during that same football game. We could plug this all back in, and we'd get a true statement, and we'd be good to go. I think we have time to look at this last one. Again, I would like you to pause the video after we read through it and try it on your own, and then you can check back in to check your answer. So this question says, Lance rides his bike downhill at a pace of 60 miles per hour. When Lance is riding uphill, he rides 8 miles per hour slower than on flat roads. If his downhill speed is 4 times faster than his flat road speed, how fast does he travel uphill? So F is his pace on flat roads, and U is his pace uphill. So go ahead and pause the video here. Give this one a try on your own, and if you get stuck and want to check your answer, you can unpause. All right, so let's take a look at what we know here. So we know that Lance's downhill speed is 60 miles per hour. And we know that his downhill speed is 4 times faster than his flat road speed. And when he's riding uphill, he's 8 miles slower than when he's on flat roads. So let's stop here real quick. So if we know that 60 miles an hour is 4 times faster than Lance's flat road speed, we can find F. So we'll divide by 4 and divide by 4. And we're left with F equals 15. So we also know that Lance's downhill speed is 4 times faster. Oops, sorry, I went to the wrong sentence. Sorry about that. When Lance is riding uphill, he rides 8 miles an hour slower than on flat roads. So his uphill time is his flat road time minus 8. So his uphill time is equal to 15 minus 8. Uphill time would be equal to 7 miles per hour. Alrighty, so that is lesson 28. Real quick, let's take a look at your independent practice. You have 5 questions. You can solve them in any way that you would like, with tape diagrams, with an equation, however you want. If you need extra space, make sure that you turn that in as well so I can see your work. If you run into any problems or have any questions, please let me know. I am here and I am happy to help. Our secret word today is tortilla. Please make sure that you get that written down somewhere on your paper. Again, remember that if you have any questions or need help with anything, please let me know or let Miss Sally know. We are both here and we are happy to help. Have a fantastic rest of your day, and I will see you all tomorrow.